Good afternoon, ladies and gentlemen. Please welcome the Chief Executive Officer of Open Compute Project Foundation, Corey Bell.
Hello, everybody. My name is Corey Bell, better known as Little Beard. Yes. See who was listening after lunch. We're so excited for this next portion of our program. Omar Baldonado is one of our project leads for the networking project of our portion of a networking portion of our project. And so we're excited to have him. Please welcome Omar Baldonado. Thank you.
Hi. Thanks, Corey. Thanks, Corey, for having us, giving us the opportunity to talk about the networking project. Carlos Cardenas and I are co-leads, and we're so excited about all the activity that's going on inside the project. We want to share a little bit of that with you today and give you a sense of why we think our project is the most exciting community, the most exciting place in networking today. Right? So to give you a sense of that, we'll start with a little bit of history. Right? And like Frank said this morning, it all started with a few of us working, thinking, what can we do differently in the networking industry? Right? And what we did was we formed a workshop. We got together just about 2 years ago in MIT and came up with the charter for the OCP networking project. You can take a look at this. We wanted networking technologies that were disaggregated and fully open. I've called those out, allowing for rapid, fast innovation in the networking space. So what does that mean, disaggregated and fully open, for the networking world? Right? I was trying to figure out a graphic to use for this to represent what was the status quo of networking devices 2 years ago. I was hunting for graphics, and actually the most simple one came up. I'm just going to use a black box. Right? So you see this picture, what do you think? You might think closed, not transparent, right? A monolith. Right? So you've heard those terms before as examples of exactly the opposite of disaggregated, the opposite of fully open. And this was the status quo for networking devices when we started the workshop, started the group a couple of years ago. So we disaggregate that monolith, and happy to report now that network disaggregation is here. All throughout 2014, the whole networking project has been working on different aspects of that monolith and trying to break it up and be open with it and have contributions into the networking space. So let's start with the hardware. We had to keep that broken out, and there are a lot of different projects working on everything from the NICs and the optics to the actual systems and chips themselves. Moving up the stack, we disaggregated software from the hardware, right? And there are all different layers inside the software that we'll go over a little bit. Finally, in 2014 and the beginning of this year, we started on the testing, really in earnest, because testing is where these technologies meet our networks. And so what I'll do now is I'll give you a quick tour of all the different active projects within networking using this diagram as an example, or as our framework. So let's start with hardware. All right? Remember the monolith, right? So how hard is it to open up hardware? But if you think about it, 2 years ago, no one had ever opened up a network switch, right? And throughout 2014, we had submissions, we had reviews, we had meetups to talk about these, and there were a lot of difficult issues to deal with. It sounds easy now, but think about it this way: like, if you've never looked at a networking switch before in an open way, you know it's foreign to have it be reviewed in front of a big group, right? And the group is chiming in on the mailing list. The group is calling in. They're saying like, "Hey, can you add this grommet here for better cabling? And can you? There's an MSATA interface there. Can you open that up and do that? And what about the testing software that you use? Can you please share the testing software that you use for this?" Oh, and then the companies who are doing the contributing, they were asking us, like, wait a minute, you want the Gerbers and the BOM files, the schematics, everything with this switch. And what about the licensing issues? What about the IP issues, right? All of these things we grappled with through 2014. It was new for us, right? But we got through it, and happy to report that open networking hardware is now a reality, right? The first OCP networking switch was accepted at the end of 2014. And this is an industry first. Nowhere else can you go and just get the design package for a switch. All of the, yes, thank you, all right, to the group, to the whole community who was working on this, right? You can get this switch now, and you can get all the design files, you can change it if you want to, anybody can build this, right? And that's sort of the openness that the Open Compute project was started on, and that we've brought now to networking. Acton also contributed a rack switch adapter. Also happy to announce that was actually just accepted earlier this week. And it allows 19-inch switches to work in the 21-inch open rack form factor. Now, I mentioned there were a whole bunch of other submissions that were happening in 2014. And all of those submissions are still active in the pipeline. And they're actually getting very close to the finish line. Right? So we have contributions from Alpha Networks, a couple of those, including the 32 by 40 switch, and the 48 by 10 switch that they're working with Juniper on. All of their submissions have been reviewed by the OCP Incubation Committee, and their design packages have been submitted as well. Broadcom's leaf spine switch has also been contributed, and they've been going through a lot of those iterations, those issues that I mentioned earlier about how do you deal with the licensing and how do you deal with opening up all of this. And so Broadcom is going through final reviews of that. Mellanox as well contributed. So we've got a deep pipeline of switches coming through, and I think we've learned how to get these switches through a little bit more quickly, and so we're looking forward to working with those vendors to bring these switches through. Now here at the summit, if those of you who were at the workshop yesterday, and if you were here this morning, you've heard of a few other contributions hardware-wise to the project. So the Acton switches that were discussed in yesterday's workshop, we have a 32 by 40 gig switch, and now even a 32 by 100 gig switch. Right? Think about that, 32 by 100 gig. That is a fast switch, right? 3.2 terabits. Right? I think the example is just show of hands, who uses Netflix? Who was watching House of Cards the last few weeks? Right, okay. Good. So think about this. That's 1.5 million Netflix movies being simultaneously streamed through 3.2 terabits of switching, right? So that's a pretty fast switch. Excited about that. Jay mentioned this earlier in the keynotes this morning. The near and dear to my heart, the Facebook Wedge switch is now being contributed. And you can see that spec, the Wedge switch is in production across Facebook data centers. This has been covered a bunch. I wanted to call out a couple of things that may be a little bit interesting for you to consider on it. It has an OCP microserver built into it. And why did we go ahead and just put a microserver into it? We wanted it to feel more like a server, right? If you saw the panel this morning from the financial folks, when Matthew and Brian were talking about how do we have management tools that we use for our server, how do we bring those to the network, right? And so for us, putting a server in there just made it feel like you're managing a server when you're managing that switch. On top of that, software development feels a lot more like server development, right? Because it's got plenty of CPU, it's got plenty of RAM, plenty of resource for it. I can just take the same Facebook image that we use on our hundreds of thousands of servers and run it on the switch, right? And I'll go over that. We'll go over that in a little bit. Finally, it's also the building block for future Facebook data center switches. We announced the 6-pack switch last month, and I believe it's actually right now. It's not out yet. We haven't contributed, but it's actually in our booth in the expo, just for limited periods of time. So it's actually out there right now. If you wanted to see it, don't leave. But it's out there right now, and it'll be out there on a rotating schedule. Also, as part of this, we engaged with a number of partners that we covered already. Acton is bringing this switch. It'll be available first half this year for anyone to order, plus all of the different software components on top of it. Cumulus and Big Switch providing commercial packages and open source packages on top of it, as well as Broadcom providing their open network switch library on top of it. All right, so that was some of the hardware projects. Let's move up to the software projects. What have we been doing there? And that's, if you think about disaggregation, right? Now that we've separated the hardware from the software, right? We want software to feel just like any other server development, right? So no need to take a picture of this diagram. There's actually zero content on this, but that's the point, right? How many people have seen a software architecture diagram that looks like this, right? Boxes, layers of boxes, some bigger at the bottom, some overlapping, da-da-da-da. That's fine. All software architectures look like this, right? And that's what we wanted for the switch, right? The switch should just feel like another a place where you develop software. It shouldn't be some arcane closed thing. We should just be able to develop software on top of it. So in 2014, the project, we focused on building blocks that others could use to start providing software on the switch. So let's zoom into a few of those projects. The first one, the Open Network Install Environment. We've covered this before at the last summit and in different talks already. But I wanted to highlight it because it reminds me, just think about where networking is. Think about where networking is in comparison to the server world, right? We have this, recall the monolith. So the monolith means that when you buy a networking device, you got the software from the same vendor that sold you the hardware, right? You couldn't load on different software from other companies. And it sounds crazy to think about, but think about where we were with the servers. Not so long ago, 15 years ago, I could buy a Sun server, and it only came with Sun operating system on top of it, right? Solaris, Sun OS, whatever. If I wanted to go run HPUX or IBM AIX on top of that Sun Solaris, on that Sun Spark server, people would look at you like, what are you talking about? You can't cross the streams that way. You know, it doesn't work. Right? So that's where the server world was before, 15 years ago, where you couldn't really mix and match software. That's where networking is right now. So we needed something like ONI to give you the option to say, what software I'm going to put on this hardware? I've got hardware here. It's open. I see it's available. But what image am I going to put on it? What network operating system will I put on it? And that's what ONI does. Happy to report ONI is broadly used. You know, all of these vendors are using it. I think at last count, 27 different platforms are compatible with ONI. It's also been the forefront of some of the testing work that we've been doing the networking project with the CNI group. And a batch of Acton switches and alpha switches just passed that level of certification here earlier in the month. And so we're starting to really put some teeth into the whole testing and validation plans within the networking group. Next building block. So now that I've got ONI, it's going to load a operating system onto my switch. Where does the operating system come from? How do you develop an operating system for a switch? Right? There's a lot that you have to do. Right? And that's typically the realm of only certain vendors, specialized smaller communities that do that. We wanted to open that up. Right? And a great way to open that up is with the Penguin. Right? Bring the Penguin, bring Linux, and use that as the basis for a network operating system. And that's what the project has been working on. It was presented last year in 2014. And now we've been able to get a number of vendors using it, both software and hardware. And it is the basis for a network operating system. You can use it as a reference design. You can hobbyists can use it. Commercial companies can use it as their basis. And it takes care of platform things like fans, right? power, just general stuff that around management of the overall system. It also includes a lot of example forwarding code as well as a development environment. So then the last building block I wanted to talk about, the SAI, the SAI. This is an amazing project, okay? And I'll go through a few slides just why we're so excited about this. It's an open multi-company effort, driven, started by Microsoft, working very closely with Dell and Broadcom and Mellanox. And it is an abstract interface on top of switch SDKs, and that enables so much, and I'll go over what that provides. So how did the SAI evolve? This is a different view of the monolith, right? With closed devices, closed hardware and closed software, you always had operators like us had to develop different management interfaces and program to different programming interfaces inside the box. Right? And this was, frankly, a hassle, right? You had to go develop everything separately for every separate box. Right? What we're driving for in the networking project is, can we have a common programming layer to access basic switch functions? Right? And with that, that enables a whole open stack on top of that. Right? And eventually, you then have full open access to the switch functions, you have common tools, and you're really focused on kind of the upper parts of the software stack. The SAI, or the switch abstraction interface, comes in here. It provides a common layer to program the open hardware underneath. So as I mentioned, Microsoft started this project. We were talking about it all throughout 2014, but it really gained momentum in Q4. And here were some of the advantages that Microsoft cited for starting the SAI work, but it's actually advantages for all of us, right? So now you have different hardware. I can have the same network software working against different hardware, right? That is the fundamental principle of SAI. Now, once you have that, and once you have defined this SAI, you can have vendors, other companies provide implementations that will give you access to this best-of-breed hardware. Right? And that lets you go faster. New chips come out, I can start taking advantage of those more quickly if they're being written to a common interface. And not just the lower layers are more consistent on top of the SAI. All the upper layers become more consistent. So you wind up with a consistent application stack on top of different hardware. And this lets you focus on things, SDN has been mentioned before. It lets you focus on more centralized, more global control and management and configuration and monitoring of your whole network. Now, just by way of timeline, you can't read this. This is sort of an eye chart here. But the main thing I wanted to highlight was it really gained steam in Q4. Right? A number of companies, including the 4 I mentioned before, got together, wanted to come and have a proposal to meet up. And they said, okay, let's get together. I think it was the first week of December. First week of December, yeah. And since then, it's been only 3 months, right? All this work has happened in 3 months. If you count the holidays in there, it's less than 3 months, right? Where we've been working on very actively. GitHub pull requests, codes being checked in, demos are being orchestrated, interoperability, right? And so later today in the networking track, there's going to be this multi-company demo. And again, this picture, you probably can't see that, so I'm just going to go through the numbers for you, right? 3 vendors and 1 operator are doing this. Dell, Broadcom, Mellanox, and Microsoft is the user, the operator driving it. Right? 2 different chips, 2 different ASICs underneath. 1 from Broadcom, 1 from Mellanox, right? All interoperating in this sort of a 4-switch demo. Right? The actual stack on top, the operating system, differs. 1 from Microsoft that they developed internally is running on a couple of the switches, I think 3 of the switches, and then 1 from Dell is on the other switch. and the actual systems themselves that have been built up. One is from Mellanox and one is from Dell. Right? So this feels like, just for those of you who are plugging together Linux systems, again, 10, 15 years ago, and you're like, let me try getting an operating system, let me try this distro, let me try this, I need a few drivers over here, and maybe it's all going to work if I plug all these things together, right? Demos like this in 3 months remind me of those days when I was ordering sort of my first white box servers and trying to figure out, where are the drivers that I can get from the community. Making this work, this is where the networking world is, and it's an exciting place to be with it. So those are the 3 projects that have been very active in 2014 and up to now. ONI, Open Network Linux, and Psi. Right? Now here again at the Summit, we've announced a couple more software projects that are taking place within the networking group. The Open Network Switch Library from Broadcom. Right? This picture is actually a picture I used all throughout last year in different presentations. Right? Simplified view, again, of software on top with an installer on top of open hardware. But all last year when I gave this presentation, I had to draw this red box around this piece. Like, wait a minute, those APIs are not open, not available right now. We had some proposals around them, but we didn't have an implementation that we could then take out and start using on OCP switches. So it was always this question mark, right? But with the announcement of the Open NSL from Broadcom, we now have open APIs against those same switches, like the Acton switches, the Alpha switches, that have been contributed and accepted by OCP. So this lets you develop network operating systems in the open source. It lets you develop applications. It even provides an interesting use case for OEMs, if you have your own commercial software, to expose access to the low-layer OpenNSL library. Right? And this is actually, just to set up my next slide, we're actually using this at Facebook as part of our FBoss deployments, right, when we're building on top of OpenNSL. So that's the other thing that we've announced today, is that Facebook is open sourcing a piece of FBoss called the FBoss Agent, again, along with Wedge, used in production across the Facebook data centers. It is the core library that does all the L2, L3, VPN, ARP, discovery, LLDP, UDP, ICMP, kind of all of that piece, all that programming of the switch, some maintaining of the state is all within the FBoss agent. The other piece of software that we've contributed, it's actually not part of, we're actually doing it more within the server management track, but we developed it as part of Wedge in the networking world, is the OpenBMC software for low-level system management of the whole board. So that's software. Hardware, software, where the rubber meets the road, right? Testing, right? And this is where it's going to get real, right? And we have a few different layers that we've been considering within the group, working very closely with C&I to make it happen. Right? So one way to visualize this, we have all these different components coming into a funnel, right? ONL, ONI, Psi, FBoss, hardware pieces, hardware and software, all coming in, optics pieces, all coming in. How do you know that they work? Right? And what's our strategy for dealing with all the different pieces in there? 3 approaches, or three prongs to the approach, a 3-pronged approach. So first thing is validation. We need to make sure that the individual OCP components work as advertised, right? And this is actually what a lot of the testing that has happened so far within OCP is doing, right? It's just making sure that, hey, switch does this, this ONI implementation implements the correct interfaces, ONL works this way, Psi will work this way. Kind of all the different software projects, as well as hardware projects, need to be validated. Then we're going to take the components and mix them up together and validate that too. And so as part of this, this is where you'll get an OCP seal or certification for your hardware or software. Right? But that's just the start, right? Second step, integration, right? What about non-OCP components? Right? It's not our charter to go and validate all non-OCP networking gear. Impossible to do, right? But we do need to make sure that we're integrating different pieces that are going to build on top of OCP components. For example, network operating systems. They're going to come onto the OCP switches. Other FRUs, other technologies need to be brought into the switch and integration tested. Final piece now is solution testing, right? And the solution testing starts with, the labs like UNH, UTSA, and we're going to start bringing those components into those labs, bringing those designs into those labs, and working on interoperability testing there. So then that way you as consumers, you as customers, as operators can know, hey, some of this has actually been validated by external labs, right? So just to call out, the number of vendors participated a couple of weeks ago on a specific interoperability testing around optics. A lot of good work throughout the whole week on that from the group. And we're going to broaden out that, right? So optics, we broaden that out now to interoperability with traditional networking equipment that isn't OCP, right? From these vendors, from a number of vendors. Because when you deploy OCP equipment, OCP networking gear into your network, it's always got to interoperate with something else, right? You're not going to just say my whole data center or my whole network is going to be non-OCP, is going to be this new OCP equipment. It has to interoperate with something else. And that's what we'll start validating as well, right? As the most highest level sort of solution interoperability testing. Right? So those are the three main areas: hardware, software, testing. Right? So now what's next? Right? 2015 roadmap. What do we got? What do we got? We're going to continue innovation and driving adoption. Right? That is the main theme of OCP. Right? We've got to keep on being open, keep on innovating, while also getting adoption up. So within the hardware space, we're looking beyond the top of rack, right? You look at some of the switch contributions already, a 32 by 100 is not a top of rack, right? Unless you've got some very, very fast servers underneath, that's a spine switch that's going to really bring you into the rest of the whole data center fabric. Right? We even had an interesting discussion yesterday about optics. 100G, but what about 200G, 400G? And we considered the open optics proposal for Mellanox in the workshop yesterday too. Number of companies, it feels far away, but it's going to get here, right? When your data centers need to be, 100 gig plus. On the software side, we've had these building blocks in 2014, but now we want to have an open software ecosystem going beyond that, right? Beyond those building blocks, can we actually get a full open source stack on top of OCP switches? Right? That'd be an interesting goal. And I heard from the financial panel, what about the management and configuration and monitoring software pieces that need to be on top of these switches? Right? Finally, in terms of testing, we just need more of it. Right? I think everybody agrees. We need more testing, test plans, more testing software, work out the SEAL certification stuff, solution testing, all that has to happen. Right? So this is a pretty aggressive roadmap for 2015. If you think about this. Plus all the submissions that are already there in the pipeline, we need to get those through. Right? So I'm going to wrap up here and think about how do we get this done? Right? How can we as a community tackle things like this? Right? It seems daunting. But think where we started. Right? Less than 2 years ago, we had the monolith. Right? Less than 2 years ago, we didn't have any of the things that I just talked about. So we just started. A bunch of us got together, right? This is a picture of the first networking project group in May 2013. We kept on meeting, right? This is us in UNH, kind of all happy taking pictures, but it's all about the community, right? We're all working together, right? And sort of breaking down that monolith. You see it's being covered up a little bit. That's the whole idea, right? So we're working on it. And then at the workshop yesterday, right? We started seeing things. So in the space of less than 2 years, right? If you told me in 2 years, less than 2 years when we started this, you would have, right, a 32 by 100 gig switch contributed. You'd have full design packages out there with multiple different hardware vendors contributing. Switch designs as well as optics, as well as NICs. Right? Software-wise, where you'd have all these building blocks in place, already validated across 27 platforms, certified on a bunch of switches already. A Linux distro where you can start contributing and building on top of. Right? Or software, like in the case of FBoss, right? If you're one of the 1.4 billion users of Facebook, odds are you're going through FBoss, right? So it's out there and it's working, right? So this is how we got from 2 years ago to today. And so our ask from the networking project, I mean, Carlos and I and the whole community, I think, are super excited about it. We ask that you come join us, right? Come join us at the SCI demo and the FBoss demo or FBoss session later this afternoon. Come join us on the project calls and the groups where we review all these submissions and we give feedback and hash it out, right? Come join us on the mailing list and in the GitHub repos, check in your code and start working on it, right? That is the only way that we're going to tackle that daunting and sort of bold roadmap, is if we work together as a community. So thank you very much. Hope to see you at one of the networking project events.